All right, thank you. My name is Braden Ganetsky, and I'm going to be talking about my program called Bask3twork, which procedurally generates symmetric Celtic knots. Very briefly, a little bit about myself. I'm from Canada. I have a mechanical engineering degree, but I work in C++ software development. I'm very passionate about twisty puzzles, and more recently, puzzles in general. Over the past few years, I've been working on this program. I'm very excited to share it. It's not about twisty puzzles, but that's just about me. So my very good friend John Hachet sent me this Celtic knot font a few years ago, created by somebody named Daniel Isdell. It's made of square glyphs that have various connection types, just like the ones you see right here. So here's capital QWE, as well as the lowercase counterparts. If you put various glyphs in this font together, you can make pretty aesthetically pleasing things like you see on the right-hand side here. So I wanted to do this automatically. So I created this program. I call it Bask3twork. It procedurally generates knots from this font using various symmetries. It's using a C++ framework called WXWidgets, but that's not super important. I would love to show you how it works, though. So this is what the user interface looks like. I'll select this area, and I'll generate something that's full symmetry. But I don't like this, so let's do it again. See, that's the beauty of So now I'll click this tile. I'll lock it, so now it's locked. And now I'll select this selection here. If you notice, some of the generate buttons are grayed out. Why? Because the boundary conditions don't allow for those specific symmetries. And that's one of the very important parts about Bask3twork. I want to make sure that it only ever generates things that are possible. So the only actual symmetry that's possible here is mirror symmetry across the forward diagonal. So let's do that. And it also respects the locked tile as well as the mirrored locked tile. So now I'll select this region. I'll lock it. Under the Generate menu, let's turn on wrapping in the X direction so that it wraps from left to right in the entire grid. Great. So I'll select this area and click No Symmetry. And now it wraps from left to right, so it allows this kind of thing too. I'll unlock it, deselect, and now I like this tile, so I want to export it. So I'll File, Export. You can copy the plain text. And you can, that's exactly what I did when I was generating my gift, which I will get to afterwards. Or you can file save, and you can keep working in this later if you want to reopen the file. So that's what the program looks like. As far as the symmetry goes, as I'm sure you can tell, it generates all knots that are subsets of dihedral symmetry D4. Correct? Wrong. It's not dihedral symmetry D4. It's actually, as far as I understand it, I think, it's subsets of chiral octahedral symmetry. I'm pretty sure that's correct, and someone here might correct me. Because the font itself is chiral, so if you take the true mirror image, it's not itself. It's not mirror symmetric. You would have to actually rotate it twofold rotation in the third dimension. I call that mirror. I know it's not technically the case, but I'm calling it mirror. So, but just so you know. Now, in terms of the knot generation algorithms, I started off with something called the wave function collapse algorithm, where you generate all the possible superpositions of every glyph that can be on each tile. I start at the top left. I collapse down this superposition, basically collapse the wave function. So collapse that down. Now I propagate the symmetry that I want. So I want fourfold rotational symmetry, so propagate that through. And now I update all the lists. This is the important part. Go through all the lists. Update all of them. If any of the lists have only one possibility left, collapse that down immediately and keep going. If any of the lists have 0 possibilities, scrap the whole thing and start over. So now we keep going. We collapse down this wave function, propagate the symmetry, update the lists, and we keep going until the whole thing is done. That's really computationally intensive. It takes forever. It works very well. It takes forever. So I tried something instead that I'm calling simplified wave function collapse, the fail-fast simplified WFC. So you only deal with one tile at a time. You generate the superpositions for this tile, you collapse it down, propagate the symmetry, and only then do you generate the superposition for the next tile. That means that you're not going through globally and collapsing down all of the lists in the rest of the grid. It just takes too much computation power. It's not as good mathematically, but it works better for my little laptop. So then I collapse this one down, propagate the symmetry, and only then do I generate the next superposition. I wanted to see if I could make this faster, so I tried backtracking, where I keep a list of all the steps that I've done, go back and then retrace a different path instead of scrapping the whole thing. It's actually way slower, so it doesn't work. But I want to try something called that I'm calling segmented committing, which I haven't done yet. I want to break down the grid into multiple regions. I do the fail fast simplified WFC, but every time I fail, I only scrap the current region instead of scrapping the entire thing. That works when I want to generate very large things like 24 by 24. Right now, I have to do that in a segmented way. Why shouldn't I just automate that? So I want to. Now, as for the gift exchange, I adapted something from Masayoshi Iwai. They made a 2-cycle game of life oscillator. That's Martin Gardner's name as an ambigram. It looks like this. I adapted that onto a 45 by 70 grid. I curated 160 unique knots, so each person will get their own. This is an example of what they look like, but it won't have the user interface here. It'll be nicely printed on a piece of paper, and yours will be completely unique from everyone else's and anything else that could possibly be generated in the universe. So if you would like to continue talking with me about this, I'm really interested. I love talking, so please contact me. Thank you so much.
Thank you very much.